And now that we've set up the work coordinate system and the stock, we can create the tool paths. I'm going to change the name of this to setup one. And now we're going to just go through the steps. I'm probably going to break this down into several videos. First thing that we'll do is face the top with a large face mill to basically clean off the little bit of material in between the top of the stock and the actual sprocket. So to do that, we're going to hit the face button. I'm going to pull from the 2026 tool library. So the 2026 tool libraries for VF3 tools. And right here, tool number 30 is our face mill. We only have one face mill in the machine. Has a diameter of 3.15 inches, and it is composed of 6 individual cutting inserts that leave a nice polished surface when it faces the material. So I'm going to do there, select that, and the speeds are already set for aluminum, so we can leave that. The stock selection is already selected. The depth by default is the bottom is the top of the model, which is what we want to do. We want to stop at the top of the model. And we should be able to leave everything as default. And then hitting OK, we can kind of see that you basically come down, go across, and the actual face mill goes the other way. One thing that we don't want to do is take too much material at a time. We can take usually around 20 to 40 thousandths of an inch is a safe depth. And so one thing I'm going to do is go back here to the passes, go to multiple depths. The default, the maximum step down is 40 thousandths. I'm going to be really safe and conservative and go 20 thousandths. You can keep it at 40 thousandths. It'll be okay with this aluminum. Notice with 40 thousandths of an inch, it's actually doing 2 passes. There are occasions that not all of the surface is faced. I've had issues where it doesn't quite get the edges, and so it'd be nice if it was a little bit wider of a cut. One way to do that is to go to under passes. We can just do a stock offset, and if I hover over it, it basically explains what it does. It says it specifies the distance the machine boundary extends beyond the stock boundary. And so sometimes you might want to just add, a quarter of an inch or something. And what that does is extends the lead-in distance here, and it makes this arc a little bit wider, ensuring that we don't leave any material on the edges of the stock. We're actually gonna, on this stock, you can see that the stock's quite a bit larger than the sprocket. We're coming back later with a tool to clean out all of this material, a 3D adaptive tool path, and so it wouldn't really matter if a little bit was left there, but we'll stick with the facing there. We do have some holes to drill and tap, and we have these areas, these spoke cutouts, and the center to be cut out as well. Really doesn't matter what order. I'm going to clean out the spokes first, and I'm going to use a 1/4 inch end mill. Basically go all the way through the stock to do that. So I'm just going to go to cam, and we're going to do a 2D adaptive tool path. Looks like right here, the 2D adaptive clearing. We need to change the tool. I'm going to look for a one thing. These are don't use these tools directly here. These are from an old tool library that I forgot to delete from the file, and so I'm actually going to delete all of these except for the tool 30 because they are for an old tool library, when I did the tool paths on this part, and I forgot to delete all of those. So I'm just selecting and deleting all of those tools. I want to choose the tool from the tool library. I'm going to choose a 1/4 inch flat end mill, but I do want the longer one, not the stub length one. So tool number 5, and that has 3/4 of an inch of flute length, and that'll be plenty to get through the 1/2 inch stock. So I'm going to go and hit select there. Again, all the speeds are set for aluminum. We will have a whole lesson on the speeds, the spindle speed and the surface speed and the feed rates and what all of those things mean. But you should not have to change any of these numbers. The geometry that we want to clear out is basically all of these arcs. Notice I'm not selecting there, but I'm selecting here because of that chamfer. Okay, and get all of those. So we're following that geometry there. And we might as well get the middle. All of that needs to be cleared out. The depth, I'm going to go just to the stock bottom. And let's go a little bit deeper, maybe 10 to 20 thousandths of an inch, just to make sure that we're going through all of the material there. And so you can see that there's the stock bottom, and we're going through. And we're going to leave a radial stock, but we're not going to leave any axial. The default is 20 thousandths for each. If I left axial stock to leave, it wouldn't go that extra distance down. Basically, it would go, I set an extra depth of 20 thousandths, but if it has a stock to leave of 20 thousandths, it would actually go back up to the bottom of the stock. So I'm just going to leave this at 0, and I'm going to leave this at, I'm going to change that to 10 thousandths. And you should be able to hit OK and see what happens here. Okay, everything looks good except it did not do the center hole. The reason why is because the default helical entry, that coupled with the diameter of the end mill, does not fit in this space. And so we could do this with a smaller tool, but a better choice would be just to decrease the ramp diameter slightly until we can get the tool to fit in the middle hole. And the middle hole is a 1/2 inch in diameter, so the 1/4 inch end mill will definitely do that, but we should change this diameter. I'm going to go like 0.2 and see what happens, and I'm just going to reduce it until, and it looks like 0.2 does work. I don't want to go too small because we don't want the machine to be jerking around, left and right as it's trying to move these very tiny movements. I basically want the largest helix I can get. And so that seems reasonable. Notice we go down, it goes a helical entry down, and then does the adaptive clearing to do all of that. I'm going to follow that up with a contour. So I'm going to right click here and then go contour. And the way we're going to do this, instead of selecting contour up here, I'm going to right click and go create derived operation, 2D milling, 2D contour. The nice thing with a derived operation is it keeps the same tool, the same geometry, and the same depth. And so we have the same tool. We're going with the same geometry that was selected before, same depth that we selected before, except now there is no stock to leave. And so it's just cleaning up that. We can do multiple passes. So we can go maybe around twice, repeat the finishing passes. And that basically does what's called a spring pass, as you see that little window that shows up. Basically, it goes around once, and then it goes around the same geometry again. Sometimes there's tool deflection. The tool bends slightly when you're cutting the material, and so this helps give you a more accurate final dimension that is more closely linked to the actual dimension you're seeking. So it really doesn't matter for the spokes much, but we do want the center hole to be as close to the right diameter as possible. So that doesn't hurt. It takes a little extra time to go around twice. And then I'm just going to hit OK. We want to make sure that all the spaces that we selected are being generated. So we can simulate that. And so I can go simulate. We can show the stock material. And I'm going to rewind it here and then just hit play. Oh, we go to the beginning. So there's the facing. And see that it's taking off a maximum of 20 thousandths of an inch per pass. It definitely has plenty of overlap. This extends way beyond the stock, so we're not leaving any material. Once that's done, we then move to the adaptive clearing. I'm going to fast forward through this. So once it's all cleared, then we do the contour. Notice it's going around 2 times. That second time is called the spring pass. All right, that's good. I'll go through some of the other toolpaths in the next video.